Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to this NPTEL course on Circular Economy for Sustainable Buildings. In the last class, we saw how sensors can be used to reduce energy consumption in buildings. In this class and the next class, we will look at energy efficient pumping and cooling systems. So, what will we see in the next two classes is, we will see what are energy efficient pumping systems. There are many. We have the variable speed drives, high efficiency pump, hydraulic optimization pump, smart control, pump scheduling, leak detection and repair, energy recovery systems, and seesaw pumps. So, if we see, first let us see energy efficient pumping system. So, energy efficient pumping systems are important for us to have good water supply, and at the same time they should be able to consume less energy and reduce the operational energy and operational cost. So, these systems can employ many technologies and strategies, because of which we will have efficient pumping system, we will have less operational cost, and we will have minimum energy consumption to get the same impact. Under this, let us see what is a variable speed drive system. So, variable speed drive will allow the pumps to operate at various speeds, which will match the exact flow requirement of the system. What happens because of this? This will eliminate unnecessary energy consumption when it is operated at its full speed. So, your output is exactly what you want, but it is at a lesser energy consumption because of the variable speed drive. Then next is high efficiency pumps. So, the centrifugal pump is generally considered to be the cheapest or most economical. This is followed by the rotary pump and the reciprocating pump. But the positive displacement pump, these are more efficient than centrifugal pumps. The benefit of high efficiency tends to be an offset by increasing the maintenance cost. All over the world, centrifugal pumps account for the majority of electricity used by pumps. Therefore, we should try to have high efficiency pumps which incorporate advanced design and materials, so that we can minimize the losses of hydraulics and improve overall efficiency. Because these pumps can significantly reduce energy consumption as compared to older, less efficient models. Third is hydraulic optimization. Proper hydraulic design of a pumping system, including, so what do you mean by hydraulic design of pumping system? The pipe size, the fittings and the valves can help us to minimize energy losses caused due to friction and turbulence. Then the next fourth aspect is smart controls. When you have smart controls, you can monitor the system performance in real time. This can allow us for timely adjustments and optimization. These systems can accurately predict the failure of the equipment, and this can enable us to have preventive maintenance and reducing the downtime. The sixth most important aspect is leak detection and repair. You need to identify and repair leaks in the water distribution system, as this can reduce the amount of water that needs to be pumped, and this can result in significant energy savings. Next is pump scheduling. So, by scheduling pumps to operate during the period of peak demand, energy consumption can be optimized. Minimizing the idle time for pumps can further reduce energy consumption. And then we have the energy recovery systems. In certain application, energy recovery system can capture and reuse the energy generated by the pumping process. This can further improve overall efficiency. So, in order to have energy efficient pumping system, we should first have high efficiency pumps, then we should have hydraulic optimization, then we can have smart controls, we can have leak detection and repair, we should have good pumping schedule and good energy recovery systems. For each of this I have told you what are the ways in which each of this aspect will contribute to energy saving. But if you combine more or all of these in a pumping system, we can really have a lot of energy conserved or saved. Next, we will look at a very energy conserving or almost zero energy requiring system, which is the seesaw pump. What is a seesaw pump? A seesaw pump is a mechanical water pump that operates using the principle of a seesaw. So, what it does is it uses the simple motion of a seesaw to draw out water from a source. So, if you have, we all have seen a seesaw, isn't it? When one person comes down, the other goes up, and in that process, there is a piston which works here, and because of the motion of the piston, we can get water pumped out into a bucket. So, this is largely used in rural areas or underdeveloped areas because this is low cost. So, low cost, easy to operate, dependent only on human power. So, these seesaw pumps are used for either irrigation or providing drinking water for smaller communities. So, this can be used in such places. Now, if you look at the design and operation of a seesaw pump, the seesaw pump is built around a basic seesaw. So, this is a seesaw. So, what happens is this up and down motion of the plank on either sides, this is done typically because of the weight of an individual, which we call as the human force. So, a human force either pushes this plate down or pulls it up. So, one end rises and the another end settles down and causes a oscillating motion. This oscillating motion will make this piston or a similar mechanism to move up and down, and that will cause pumping of water. So, basically it is very simple mechanics. This pumping action will utilize this piston or the diaphragm pump design, where each motion of the seesaw, this creates suction that pulls the water up from the source through an inlet pipe and then pushes it out through an outlet pipe. The inlet pipe is somewhere inside this, and this is the outlet pipe. So, one big advantage of this system is its low maintenance cost. So, it is a simple design and ensures that it is easy to maintain and it is very inexpensive. Replacement parts are also available easily, or if it is not available, you can fabricate any of these parts easily. Then its biggest fourth characteristics is it is human powered. This seesaw pump does not require any electricity or fuel, making it very ideal for remote areas where you do not have those resources. Your resources are so limited there. So, this system will involve primarily children or adults who move up and down on the seesaw as a playful activity. And in that playful activity, they can generate the pumping action with which water can be pumped to a container. If we look at its capacity and efficiency, so these pumps are not supposed to be used where you need large amount of water to be pumped. They are intended for high capacity systems, but they are effective only for small scale water needs. The small scale water needs can be like irrigating small farms or supplying water to households. These are the requirements, not like for an office building or a commercial building pumping the water. It is not useful for that. So, this efficiency is directly related to the force applied and the number of strokes or number of times per minute that the seesaw plate moves, and therefore the piston movement. So, it is suitable only for moderate water needs. These also have another name called as joy pumps, because you are able to pump out water because of a very joyful, playful activity. So, where is it that this can be used? This can be used in schools. What part of schools? This can be used in schools for drinking water, for pumping out the drinking water, or even for sanitation, or even for personal hygiene. Then their next uses, this can be used in institutional buildings. See, there should be people who are willing to use the seesaw, isn't it? So, in schools and institutions, it is no, easily we can have children or students use it. So, for institution buildings, we can use it primarily for drinking purpose and maybe to some extent for sanitation purpose. Then these can be used in public gardens, because there will be more children coming and playing in public gardens, this can have a usage. So, we can use this for drinking, sanitation and watering the plants. We can have many of these installed, and then the plants of that particular area can be watered. Then these can be used in community centers. Community centers. So, in community centers, they can be used for drinking water, pumping out drinking water, or even for sanitation facilities. Then these can be used also in small communities to pump out drinking water, and they can be used in refugee camps, again for smaller requirement like drinking water. So, these are the ways, or these are the places where these joy pumps or seesaw pumps can be used based on how many people we have who will be willing to joyfully operate or play, and therefore we will be able to pump the water. Now, pumping water energy efficiency is one aspect of a seesaw pump, but there are certain economic aspects also, and there are social aspects also. Economics and social aspects of joy pumps or seesaw pumps are there. So, see, it uses the playful energy of the children or people who are operating to collectively pump out water. So, the seesaw pumps, which actually use the force lift technology to draw water from an underground well to a overhead tank above the ground level for storage and distribution, or sometimes even at ground level like this. So from the seesaw pump, water can either be pumped to a overhead tank and then this can be supplied, or their other way of doing it is that from a seesaw pump, water can be pumped out and it can be captured at the ground level also. But then it uses a playful force lift technology. So, most importantly, when this experiment was done on some African villages, they found that when you use this technology, children understood the value of water because they are fetching the water themselves. It is their own effort they see which comes as drops of water. So, through seesaw pumps, they were able to learn this thing very carefully, that water is a precious commodity and it takes a lot of effort to get one bucket of water. Then what happens is this also reduces the dependency of school on other sources, where in poor African countries or some other very poor countries, electricity is not available to that extent. Then the fuel for water supply, which is primarily pumping, is not available. Hence, changing the face of a particular place by giving water, which initially did not have water, set a very good example to other schools. The play pump seesaw is installed in schools in rural Africa. So, they found that when the children play on the seesaw, the energy created by the movement draws water up from the borehole. The two pumps connected to each side of the seesaw displace water with every movement. So, these are the two pumps. So, with every movement water is displaced and up into a polythene tank 7 meters above the ground. One large social aspect that came up was it was a community initiative. One person will not be able to pump out water. You need minimum two people. And therefore, it was seen that in this African village, apart from creating a awareness about water conservation and importance of water, it also brought the society and the people together to work for getting water and understand that it is a scarce resource. So, seesaw pumps are very useful and effective as a energy conserving pump which uses almost zero electrical or grid energy but relies primarily on human force and human energy to pump out water. One of the best examples of energy efficient pumping systems. So, today we saw about energy efficient pumping systems, and with this we stop today's class and we will continue in the next class. Thank you.